Hello everyone. In today's video, we're going to look at some soldering. We're going to introduce it, look at the tools that are necessary to be able to solder, and look at some safety tips, safety towards you and safety towards the equipment as well. So let's begin, and a good idea to always start is to have all your tools out and ready, right? So a few things that we need when we're talking about soldering is first and foremost the soldering station or soldering unit or soldering pen, soldering iron, whatever term you want to use. We have a paste system here. It is temperature regulated, which means we can set a temperature and it'll keep that temperature as we're doing our work. This is really something, some kind of system like this is something that you want to have when you're doing any real soldering work on printed circuit boards or PCBs. There are these other things, and some of you may have these. We usually call them soldering pens or soldering iron pens that you plug into the wall. They're perfectly fine for small tasks, small jobs, little home hobby things. But the issue with them is that they're not temperature regulated. So, if you have a fan blowing, it actually affects the temperature on the tip. If you have a very big copper pad that you have to solder to, copper's metal, it pulls heat away, so it reduces the temperature on your tip and can cause issues as you're trying to solder. So they're okay for small jobs and tasks and things like that. But really, when you start building and designing circuits on PCBs, you really want to have a system that has some sort of temperature setting. Next few things, you should always have some cutters for cutting off legs. Of course, you don't do any soldering if you don't have solder. Solder is made of various metals that when heated melt and with the heat bond to the copper and the component that you're trying to solder to. We'll talk a bit more about solder in a few moments. Next thing is of course, I'm using this sort of vector board PCB. So there's holes everywhere, but they have little copper pads on top so that you could put a component through and solder to it. So you'll need some sort of board like that. You will need some sort of tips. Okay. We have 3 of them here. And in essence, you need to decide based on the size of your pads on the PCBs. So the size of the copper pads where you're going to be soldering components to, you want your tip to be of the same size as the pad that you're working with. So you can see we have, for example, something called a chisel or large chisel tip, really good for larger pads. You also notice that there's a bit of a bump there, and that bump is actually some solder, and I'm going to explain in a few moments why we have that there. We have another one that's called a conical, which is basically just a little point, right? This is for smaller pads. And then for most of our tasks, because the pads fit right, we're going to use a small chisel tip. Now, it's hard to see that this is actually a chisel tip because there's quite a bit of solder on top of it. And as I said, I'm going to explain in a few moments why we have that solder. Next thing is this little silicone pad. Super useful if you need to change tips while working. Okay, the tips are going to be super hot. You don't want to handle that with your hand. You don't want to have to turn the whole system off and on every single time, waiting for the temperature to come on and off. So it's very easy to just pull a tip out, put a new tip in, and continue working. All right. We're also going to use something called flux, and this is a flux pen. It's a special type of liquid or rosin that you put on your components, your pads, and essentially when it gets heated up, it helps to clean the pad. And so I don't know if you've ever painted in your life or saw someone paint. One of the most important things when you're painting is the wall must be clean. And so you often wash the wall, sometimes wash it with some special material, cleaning thing called TPS. and then you have to put primer on it, and then you can paint. And all those steps are required to ensure that the paint adheres to the wall. Well, Flux does something similar. It cleans the pad, it cleans the area of any impurities, oxidations with the heat. It pushes all that away and helps for the solder and the copper and the leg of the component to bond together on a molecular level to ensure that nothing moves, nothing comes apart. And then last but not least is, or actually maybe it is least, you need some sort of solder remover, all right? We have something like this that uses sort of a reverse vacuum. You push it in and it will suck up solder. We also have these solder wicks, right? We really hope not to ever use these because this is really not great. It doesn't produce an amazing result at the end. So you want to make sure that you do a good soldering to begin with and not have to worry about these things. If you do have to do some kind of desoldering, it's best to have what we call a rework station. But in a pinch, your solder wick or a solder remover like this will do the job. All right, so having said all that, I'm just going to move a few things so that we can go to talking about our station now, or soldering station. You'll notice it comes in a few parts. This is the part, the base, where we set the temperature. We will want to set our temperature to 500 degrees Fahrenheit or about 260 degrees Celsius. And I'm set to that right now. That is the temperature that works really well with lead-based solder. It helps it melt really quickly. It doesn't put too much heat on our board because that's a bad thing. So that's a good starting point for us. Now, what temperature you're going to use does definitely depend on the solder that we use. Okay. Next, you're going to see this is where we put the solder tip inside. All right. Then you have your base that holds the whole solder tip. And we have two things here. We have something, for lack of a better word, is steel wool. Well, it's not really steel wool, but it's close enough. And we have a sponge. And really, you should go moisten the sponge. Don't fill it with water, but it should be moist and a little bit wet. And these two things are used to clean the tip as you're working because you want to make sure that the tip is nice and shiny, doesn't have any bits on it, doesn't have excess bits of solder sticking to it, any kind of dirt. You want it all gone. All right. So let's now put in a tip. I'm going to take my chisel tip, remove the other two away, and you'll notice that in the handle here, there's a little notch. And if you look at the tip, you can kind of see there it is. There's that little notch. And so that notch fits perfectly in there. And you want to push the tip all the way down. It doesn't click, but it goes all the way in and it holds. All right. And we can now put that back and we will turn on our base now. You'll see that when there's no tip, the little LED is going to be red. As it's heating up with a tip in it is going to be orange or amber. And once it heat comes to the right temperature, it'll turn green. So now we're at green. We're good to go. Our iron is hot. And what that means is do not touch this part here. Okay, nothing here. All the, I guess, black handle part is safe. It's protected. You can hold that. You can hold the cable, the wire, but do not touch that part. Okay. Inevitably, someone's going to burn themselves, but hopefully not. All right. But this is now at 500 degrees Fahrenheit or 260 degrees Celsius. It is super hot. Now, before we start working with it, we need to make sure that we clean the tip. And as you saw, and as you can see, there is stuff on it, there's solder on it. So using the sponge, we can wipe stuff off. If you find there's still some on it, you can use the steel wool to clean it. And now you have a nice, clean, shiny tip ready for soldering. We put it down and we'd start soldering. I'm going to save that for another video. When you are done soldering, or you want to take a break, or you want to put the soldering iron down, even if it's for 10 seconds, do not simply put the iron there. What you're doing is you're risking the iron from overheating, getting burnt, and oxidizing. And if that shiny tip goes black, you've essentially ruined the tip. These tips are expensive, they're not cheap, okay? A few $100s sometimes. So you do not want to do that. So even if you're putting it down for 10 seconds, literally 10 seconds, you need to take some solder and you need to apply it to the tip. So touch it to the tip all around and make sure it's better to have more than less, okay? And this process of putting solder onto the tip and then putting it away is called tinning, all right? You must always tin your tip before using, and you must always tin your tip when you're putting it back down, okay? Even when we're turning it off, like we're finished working, you must tin your tip. Nothing worse than forgetting to tin your tip and ruining a soldering iron tip, okay? So that's why we do it, is for the protection of the tip. Now, I want to take a little note and mention, I hope you notice that there is smoke that is coming up, okay? Why is there smoke coming up? Well, inside the solder is a little bit of flux. Remember the flux that we talked about? And so you really don't need extra flux when you're first starting because there is some flux in the solder. And all that's happening is that the soldering iron is burning off that flux. Now, rest assured that flux is not, or that fume, the smoke that's coming up, is non-toxic. You're not going to get sick from it. You're not going to anything from it. Okay. It's absolutely non-toxic. Having said that, some people are more sensitive. You may feel a little lightheaded if you inhale it too much, which is not really surprising. Some people may even develop a headache. So every station should have a fume extractor or some kind of fan with a carbon filter on it to remove the smoke away from you, okay? And to clean it essentially. So by all means, always have something like that on, just for, just so that you don't get a headache, all right? I'm not particularly sensitive to it, so it really doesn't bother me. The only way it would really become maybe problematic is if you did like 8 hours of straight work soldering, and then you'd have to maybe be a little more protective of yourself. But ultimately, it's not the end of the world. Okay. Now, a little word about the solder. So I mentioned that we're using lead-based solder. This particular solder is 60% tin, 40% lead. We use this because it is fantastic to work with. It creates excellent solder joints. It's super easy to use. It melts at a lower temperature or fairly low temperature, and it is hard to really screw up a solder joint using this type of solder. Now, of course, the issue is that it's lead. So there is lead in it. And so after you finish working with this, after you've manipulated it in your hands, make sure you wash your hands. Don't rub your eyes. Don't put your hands in your mouth. Wash your hands. Okay. Again, you're not using enough to cause you any damage, right? It's not like you're eating this and chewing it and swallowing it, but it is lead and you need to be careful with it. In consumer electronics, they don't let you use this. They actually have an ROHS standard that requires a silver-based solder. Now, the problem with silver-based solder is it requires much higher temperatures. It is far easier to create what's known as cold solder joints. Cold solder joints basically is solder that doesn't properly adhere to all the materials it's touching. So it doesn't adhere to the copper pad, the leg of the component, and it becomes kind of dull and over time becomes much more brittle and can crack, unlike lead-based. So for that reason, we're using this. NASA uses this. High-end military components use lead-based solder, so I don't think we're making a mistake in using this, all right? And that's about it. We will have another video where we're actually going to show some soldering techniques, but I highly recommend reviewing some of these things, remembering your temperature, remembering the tinning, and that's about it. Have a great day.